Okay. So once again, good evening to everyone. Welcome to these live sessions in Control Engineering course, which is part of the BS in ES course. Okay. So my name is Chakravarti Jeda. I'm a PhD scholar at IIT Madras, working with Professor Ramakrishna Pasamurthy sir. And here with me, Dr. Valli, you can see madam's face also. So she is also visible here. Okay. So she's a postdoctoral associate working with Dr. Ramakrishna Pasamati sir. And along with us, there will be one more instructor, uh, Vasumati, was Miss Vasumati Raman. So we three will be taking these live sessions and handling these live sessions as well as all these assignments, etc. Okay. So with this small introduction, okay, so I'll start the session. So give me a minute.
Good evening, everyone. Am I audible?
Yes, ma'am.
Yeah. Can you all have some quick introduction about you so that we can understand
Yes,
what,
yes, I
what
think
your
that is
background?
better.
Yeah, that will understand your that will decide we can take how much space we have to teach for you.
Yeah, yeah. So just with your name and where you from, that would be
Yeah,
fine enough.
that's good.
So
Yeah.
I'll call names wise. Okay. So first, Pavan Chitte.
I'm audible, sir.
Yeah.
Yes.
Yes, sir. I'm Pavan and I'm from Karnataka. Currently, I'm in last term of my diploma level.
Okay.
Okay.
Thanks. Yeah.
And
Soumya. Yes. Yes,
one
ma'am.
second. You are only taking this course, or you are having
No, I have
as a
another course,
student?
sir. So I have sensor and application,
No, no, I
like
just wanted to know
degree.
your. Uh, okay.
I'm a standalone student, actually. Standalone.
Oh, okay, fine.
Okay. Next to Soumya Goal.
Um, Good evening. I'm
Yes.
Soumya and I'm from Delhi. I'm also doing the standalone and I have two more courses with this.
Okay. Thanks. Next to Srinivas SV.
Yes, sir. Good evening, sir.
Good evening.
I'm Srinivas and I'm from Bangalore, sir. And
Okay.
I'm
Okay.
also doing MSc Electronics. Uh,
Okay.
it's my second degree.
Thanks.
Yeah.
Yes. Next to Abu Shahama.
Yes, sir. Good evening, sir.
Good evening.
I am Abu Salma, and I am from Uttar Pradesh, and I am also a standalone student.
Okay. Thanks. Next to Sahil Raj.
Hello, good evening all. Myself Sahil Raj. I'm from Bihar and currently I'm in starting of degree level and I'm standalone student.
I
Yeah.
just want
Thanks.
to know one thing. Standalone student means you are having working in some other industry or something and taking as along part with this BS course as it is, right? Or you are a student and taking another BS course as another course for you.
Can anyone give the reply?
Are you having any industrial experience?
I think most of the students join after the 12th, and some have also have doing work in the industry.
Okay. Next to Sneha.
Yes, sir.
Yeah.
So what I have to do, I have joined right now. So,
Oh, okay. Okay. Fine. So just to tell us where you are from and in which part, in which stream you are doing this course.
I am from Jharkhand, Ranchi, and I am a dual degree student. Uh, I am doing Bachelor of Computer Application from Ranchi Women's College and another Bachelor of Electronics from IIT Madras.
Oh, okay, okay. Thanks a lot.
Thank you,
Uh,
sir.
Tanmay Yadav,
Yes, sir. Good evening, sir.
good evening.
Sir, I am from Uttar Pradesh, and I am currently in my diploma level. I am also pursuing this degree as a standalone student.
Oh, okay, thanks a lot. Next, we have this name DMX 4120.
Hello.
Your
Good
name and yes, good evening.
evening, everyone. My name is Suvadim Mandal, and I am from West Bengal.
Okay, all right. Yeah. So thanks a lot, everyone. Let me share my screen. So hope you can able to see the screen.
Yeah.
Yes, sir.
Yes. Yeah. So as I said, we have three instructors. Okay. So myself, Chakravarti. Okay. So and Dr. Valli. So and third instructor, Miss Vasumati. Okay. So Vasumati Raman. Okay. So and these live sessions. So we'll be having sessions. One on Tuesday and another one on Thursday. Okay, so both will be from 5:30 p.m. to 6:30 p.m. Okay, so it means that we'll be having sessions, two sessions. Okay, so these are 1 hour sessions. Okay, 1 hour each. So every week we'll be having 2 hour sessions. Okay, so 2 hour sessions for live sessions. So the thing is, the basic doubt is what we are going to do in these live sessions. Okay, so the main thing we do is so every week. So whatever the content we have for this control course, so that is weekly wise. Okay, so we are going to cover the weekly content exactly the same. Okay, so on track with the videos. Okay, so uh, mostly every week. So if you see the course, you'll have some 4 to 5 lectures. Okay. So these lectures in the form of the videos. Okay. So delivered by sir. Okay. So Professor Ramakrishna sir. Okay. So uh, being students, what you need to do is before coming these live sessions, okay, so we expect that you will be going through those videos completely. Okay, and when we start the live sessions, okay, first what we do is we'll do the quick review of the content. Quick review in the sense we are not going to explain very much in detail, okay? Because basically these live sessions are meant for doubts clearing as well as majorly for problem solving sessions. So the problem solving sessions for this course are going to be very much useful for you, okay? So if we spend more on the problems, you'll understand more after having gone through those videos, okay? So that's why we said we will do the quick review of the lecture material covered by sir, then followed by the problem solving. Okay, so on that material. Okay, so it is not that we do quick review without going for the much explanation. Okay, so there are some topics in this course, okay, where when we enter into the week 6 onwards, so there are little advanced. So at that time we'll try to spend more on the theory also. Okay, so then problem solving, it is kind of mixed thing, but basically before week 5. Okay, we'll try to solve more problems so that you will understand more of the subject. Then later weeks it will be easy for you. Okay, so is this clear? And also apart from this, we have this discourse discussion forum. Okay, so where in this discussion forum you can discuss with among yourself, all the students. Okay, so we three instructors will be watching the discussion forum. Okay, usually we don't enter in the middle of the discussion until unless we wanted to clarify things where almost all the students got stuck, or we'll try to do the corrections in your discussions. Okay, we wanted to make the discussions student friendly. Okay, but we'll be watching all your uh, uh, content related discussions. Is this clear? Do you have any queries? And every live session, okay, so we'll be recording. Okay, so within maybe mostly next day. Okay, before next day, so we will upload to the YouTube, and we will make sure that that link will be provided to you. Okay, so because most of the students, they may not join these live sessions between this 5:30 p.m. to 6:30 p.m. So they will be working somewhere else. Okay, they can watch those live sessions later. Okay, mostly we'll make sure that that will be available by next day. Okay, so apart from these, do you have any queries regarding these live
Ma'am,
sessions? How we operate? Yes.
ma'am, live session notes also will be uploaded, right?
Yes. We
Uh,
will give the live session notes also. Like suppose
okay.
now you see this PDF copy. Okay, I'll be mostly we will share one Google Drive link. That link will be available to you all the time. Okay, so you can, after this lecture, you can get that notes also.
Okay, ma'am.
Yeah. Any other queries or doubts?
Sir, I have a doubt regarding the
Yes.
lab part in this control engine. It's a
Okay.
quiz
Yeah.
lab or final lab?
What is it?
Lab. Like we have to demonstrate something in uh, MATLAB, correct? In this course.
Yes. So in this, so if you see our the website, course website, every week we'll have practice assignment, graded assignment, correct? Apart from this, okay, so almost at the time of week 8 or week 9, okay, so we'll have one handwritten assignment. You'll have to submit one handwritten assignment plus one MATLAB based design experiment. So MATLAB based design assignment also. Okay, so two assignments you have to submit. So one handwritten assignment and MATLAB design assignment. Okay, at that time we will also teach you the basics of MATLAB, how to use. So particularly using these control system toolbox, etc. Okay, at that time we'll give specific instructions, and we'll take extra sessions also. Somebody has posted a message. What do you mean by every week? What do you mean by every week? No, not every week. So overall course, you have to submit one MATLAB design assignment and one handwritten assignment. Those two assignments we will be taking after week 8, not now. Every week you'll have to you have these two options. You have to do these two as part of your curriculum. Okay, so these are part of your course website. Okay, so Purnima J. Kumar had a doubt in week 1. How can we simulate predator prey pendulum models? Okay, so I mean, you wanted to simulate these. you can write a mail to us. Okay. So we will give you an instructions. So based upon Python code or MATLAB live sessions, MATLAB basic tutorials, you can use them to plot if you are much interested. Okay. So we'll also share you the details. Okay. So I think we'll the course website might be having our emails. Okay. What is it? It was required for grading an assignment. Which one? Yeah, I forgot to tell you. So we'll be having the surprise quizzes also. Okay, that is important. Okay, we'll be having surprise quizzes in every live session, mostly. Okay, so these will be based upon the content we will cover on that day. Okay, so every live session we'll be having surprise quizzes also, mostly. Okay, so that will be like, suppose if I take the live session this today. So at the end of last 10 minutes or 5 minutes, I'll give you a question. Okay, so which you need to mail me, or I'll give some upload link also. So apart from these, surprise quiz, yes, it will be pen and paper only, not multiple choice. It will be pen and paper. Mostly that will be depends. That will cover the session lecture.
No, he's asking about the quiz 1 and quiz 2.
Oh, sorry. Quiz 1 and quiz 2 will be completely computer based. Mostly quiz 1, quiz 2, and end exam. Okay, that will be computer based, all the three. But if there are any changes, we will let you know. Okay, so as of now, assume that they are computer based. So they are not just having multiple choice questions. So multiple answers, comprehensive questions, fill in the blanks. It will be mixed, but they are not pen and paper. They will be computer based. All right. Simulations were required for a graded assignment actually. So maybe people might need. The video instructor had said he will post the code. Apologies. I did not understand your question. Purnima, can you open your mic and tell me? Yes, Purnima. Okay, so are there any other queries? Any other queries?
Am I audible?
Yes.
Yeah, so I wanted to ask for the simulations, because in graded assignment, last two questions, the damping coefficient related question was there. So we were required. It was written that we had to use simulation to find out the answer. So, but I didn't find any simulation code anywhere, and instructor had said that for predator prey model he will post the code. So that's why I wanted to ask.
Okay, in week 1.
Yes.
Okay, week 1, which question?
Last two questions, 11 and 12.
Okay. So we'll verify once and we'll get back to you before the next session, in next session itself. Okay.
I am not sure if I'll be able to attend the next session, but if there is anything, will you be able to share it to like all the students?
Yes.
It's go first.
Yes,
Okay,
sure.
thank you.
Yeah. Yeah. Any other queries or doubts? Okay. So now that everyone on this week one content, okay. So I'll start with the week one content. So you will understand how we are going to manage these live sessions. Okay. So basically in week one content, okay, so we have 5 lectures. So in these 5 lectures, these are the topics professor has covered. So initially, uh, he defined the what exactly the control system and some system properties. Okay, so in control systems, 2 things: feedback and feed forward concepts. So followed by what is open loop and what is closing loop. So what are different components of the closing loop systems or in a control system? Okay, so these are very basic things, these three. Okay, then uh, sir has explained different classifications of systems. So what is static system, dynamic system? So what is linear system, non-linear systems? Okay. So time invariant, time varying systems. So causal systems and non-causal systems. Okay. So for every system type, okay. So sir has explained mathematically how you can verify the uh, whether it is a static system or dynamic system or any of the other systems. Okay. So in this live session, what I'll do is, okay, so I'll take linear versus non-linear. Okay. In the next live, so I'll cover the other 3. Okay. So particularly based upon the problems. Okay. So these things, just knowing the definition may not give you the right thing. So if you solve more examples, okay, that will be of more useful to you. Okay. So let me start with the linear versus non-linear. So before that, okay, so hope everyone understand the importance of or difference between this open loop and closed loop systems. Okay, so here basically open loop system, if you start with that, okay, so where you'll have a plant. Okay, so let me take another page. Okay, so open loop system. So if you consider a fan, okay, and if you consider the regulator, fan regulator, okay, so if you apply or change the knobs in the regulator, okay, so fan will rotate to at particular speed. Okay, let us say if you wanted to run the fan at around at say 1000 rpm. Okay, so let's say in regulator you have to you have to change the regulator position to, let's say, position 3. Okay, so we expect that the fan will rotate at approximately 1000 rpm if there are no discrepancies in the fan. Okay, so where here the thing is that we move the regulator to position 3 and we expect that fan will rotate at approximately 1000 rpm. Okay, so we don't see whether exactly the fan is running at 1000, because if it runs at 900 rpm, we cannot do anything. Okay, we want only this, and we change this to 3, and it will run, let us say, at 900 rpm. Okay, so this is due to the bearing issues or motor issue inside the fan. Okay, so this is how it goes. We want something, we will apply we change the regulator, and fan will act accordingly. Okay, whatever the speed we get, okay, so we cannot do anything with that. Okay, whereas in the closed loop system, okay, so if you consider same scenario where we have fan, okay, we have regulator, Okay. So in the same way here, suppose if you wanted to run your fan at 1000 RPM. Okay. So what you do generally in the closed loop system, we have something called as the controller. Okay. So this controller will tell you, okay, so to the regulator, to which position you have to move. Okay. So whether you have to go to the 3, 1 or 2, let us say the regulator, as we said, 3 is the right position to get the 1000 RPM. Okay. So then we apply the regulator to 3. So now let us say the fan, instead of running at 1000, it is running at 900 RPM. So because of the components discrepancies inside the fan. Okay. So now the issue here is that between open loop versus closed loop is that if you can have some measuring instrument which can measure this fan speed. Okay. So in technical words, we will have this uh, uh, tachometer. Okay. So which can measure the running speed of the shaft of any motor. Okay. So this tachometer can measure it as 900 RPM. Okay. So this reading, you can give it to a error measuring between the, so the desired is 1000 and this is the actual. Okay. So which you are measuring and passing it here. Okay. So it will measure the error difference between these two. So you have plus here, minus here. So which will give you an output of, let's say 100,000 minus 900. So the controller basically what it does is it takes that 100 as the input and it will give an, so it will give an updated input. Okay. So updated instruction to this regulator. Okay. So accordingly, the regulator will move its position from 3 to some other location. Okay. Let's say that new location is something else, maybe 4. Okay. So this 4 now will apply to the fan and let us say now new speed will be 950 instead of 900. Okay. So this cycle, again, this 950 will be read by this tachometer and again it will be passed to this error measurement. Okay. Now we'll have the error of 50. Again, controller will act. So this cycle will so repeatedly do this task until we get here 1000 RPM. Okay, so basically the difference between open loop and closed loop system is this path. Okay, so this path taking the measuring the actual value using the tachometer and giving it to this error component. Okay, so this basically we call that is as the feedback. So feeding the actual output to compare with the desired input. Okay, so this is how the closed loop system will work. Okay, so in the control system language, basically we call this is as a system or plant. Okay, and so this we call it is as a controller. So this course is all about what is exactly how we are designing what we are going to do inside this controller. Okay, how exactly it produces this input. Okay, by taking 100 here, what it is doing inside and producing what. Okay, so this course is all about studying the design of these controllers. Okay, before going to the design of these controllers, we need to understand various things that, okay, so how these plant or systems will react to different inputs, etc. Okay, so I hope this idea is clear. So open loop versus the closed loop system. Okay, so why I'm explaining this is, so let us say after finishing this course, you wanted to apply these techniques, okay, control system techniques to any of these systems. It is not that you are an electrical engineering, you will apply these to electrical applications like fans, traffic lights, or robots, or drones, aircrafts, etc. No. So the control system course is the general course where you will apply these things to many fields. Okay. So the next step what I'll do is, so first you understand that field and bring that description or problem statement into something called as this structure, block diagram structure. Okay, where block diagram structure will have, you need to identify what exactly your plant is. So what kind of controller you wanted to put over there, what exactly you wanted to control, what is your design, what is your actual point, what is the feedback here. Okay, so I'll take up one example and explain you. Okay, so now you can read here. Okay, so we all know these quad rotors. Okay, so quad rotors basically, what do we have? So in quad rotors, we'll be having the 4 rotors. So in middle we have battery. Okay, so here we have 4 rotors. Okay, 4 rotors. So they all will be connected. They will rotate with the help of the motors at their locations. Okay, they all will be connected. All these motors will be connected to the battery. We place at the center. Okay, so we call these as the quad rotors because we have 4 rotors. Okay, based upon the number of rotors, so there will be hexa rotors, etc. Okay, so if you read, so here we have 2 parts. This part is definition of the problem. Okay, definition or description, what exactly this code router is. Okay, then the other thing is discusses about the, so the closed loop system. Okay, closed loop system or control system which you wanted to define. Okay, so basically what is happening is in pod rotors you have these 4 rotors. Okay, so when you apply the, since we have the 4 the 4 motors. Okay, so you can rotate the motors clockwise and anti-clockwise. Okay, so based upon the pair of motors, okay, let's say these two pairs. Okay, so our 4 if you apply the clockwise direction or anti-clockwise direction, so accordingly as per the Newton's third law, okay, so the opposite force shall be created, right? So accordingly the quad can move up and down. Okay, so we call them as suppose if it stays at the same location, we call that is as hover. So going up is called as the climbing, then coming down is called as the descending. Okay, so also there are 3 things. Okay, so every chord can do. Okay, so roll, yeah, and pitching. Okay, rolling means, okay, so now we have this chord. Rolling means, so rotating this in this direction. Okay, so this is called as the rolling. Okay, eyeing means, so moving in this direction, either left side or right side direction. Okay, pitching means, so going up or down. Okay, so going up or going down. So like you see that these 2 will be fixed. These 2, okay, by changing this, so we can climb or we can go down. Okay, so by combining all these aspects, by combining all these operations, we can do multiple maneuvers with the quad. Okay, so by changing, we can keep the quad at the desired attitude. Okay, so this is the quad rotor operation. Now the thing is that, so for every control system engineer, so this is the operation I have given. Okay, so you should understand how to put this one in the form of the block diagram. That is more important. So once you put that into the block diagram, you will understand all these things. What is my plant? What is the controller? What is my desired thing I wanted to achieve? Okay, what is my feedback here, etc. Now, for this example, I'll quickly show what are these components. Okay, so first, let me start with, I have quad here. So quad rotor. Okay, so quad rotor can do many things. Okay, so it can do roll, yeah, and pitch. Okay, so first what I wanted to do is I wanted to measure those things. Okay, so to measure, so I'll be using some sensors. Okay, so sensors like which can measure the acceleration, I can also measure its position using GPS. So I can also use some gyros so to see its orientation. Okay. So now let us say the quad is at 1 meter. I wanted to put that quad go to some 2 meters height. Okay. So let us say the first my what I wanted to have is desired position, the 2 meter height. Okay. Now, since I have desired position, I need to have something as actual position. Clear? So now I wanted to compare these two things. Okay. So here we have this summing point or comparator. Okay. So you wanted to compare these two, desired versus the actual. So I'll take here feedback. Okay. Since I'm measuring already using all these sensors, this is the feedback. Okay. So basically, what is this desired position is, since we are in the 3D world, the desired position is, so XY and Z desired. So also we'll have orientations in 3D direction. So we have pi D, let's say theta D and psi D. Okay. Similarly, we'll have the same things at actual level also. So pi A, theta A, psi A. So three orientations. Okay. So now this can give some error signal. Okay. So between desired versus the actual. Then we'll have the controller. We have the controller. So then this controller will use this error signal. Okay. Then it will guide the actuators. What are basically actuators here? The actuators are nothing but the motors, 4 motors who are connected with these 4 propellers. Okay. So then that will be given to the quad rotor. Okay. So basically here, this part, okay, so which goes from the controller to the actuator here, this we call it is as a control signal. Control signal. Okay. So this is the structure. Now you see that. So you have given the definition of your problem. Okay. So the entire operation. Okay. So now I've decided I wanted to put my quad rotor at a particular desired position. So based upon the goal and the operation which I know, okay, for this plant quad rotor, now I've kept everything in the closed loop system. Okay. So this is most important for a control engineer. Is this clear? Any queries? Okay. So it means that in nature, there are many closed loop problems. Suppose in the video, sir has explained about the predator prey problem. Okay. So those kind of problems, they are not basically electrical engineering. Okay. So they are different problems. Similarly, you could have the problem from the economics. Okay. You could have a problem from the bioengineering. You could have a problem from the state country policies. Okay. So that's why control system is not restricted to electrical engineering. So it can take any problem. It can handle any problems. Okay. From the outside fields also. Okay. So the basic aim for the student to understand that problem and put that problem into the block diagram, something like this. Okay. So I hope this is clear. So let me tell you one more example. Okay. So this example, I'm leaving it to you as an exercise. This example is basically about the data center and the thermal regulation. So nowadays the data science field is emerging. Okay. So we are having these data centers. Okay. So the expectation is to handle with more data. So we have to maintain the temperature levels at constant level. Okay. So at desired temperatures. Okay. Again, here, this is the description of the problem. So what exactly a data center is. Okay. And how you wanted to do this. This is the block diagram description. Okay. So it is the closed loop control system problem structure. So you can read these both. So once I give these notes, you try to form the block diagram. Okay. So next, you'll see this simple example. So Vikram Moon lander. Okay. So the few years back, ISRO has recently launched this Chandrayaan 2. Okay, where this this Chandrayaan 2 mission has this to orbit around the moon. Okay, it has this Vikram lander. Okay, so Vikram lander basically has done this smooth landing. Okay, so inside this Vikram lander, we have this rover, Pragyan rover. Okay, so which will detach from the lander and collect the data and reach the moon surface. Okay, so this is about the uh, lander. Okay, and this is about the technicality of the rover. Okay, so basically it consists of the attitude control system. So to control its orientation. Okay, so it needs to get to the desired attitude. Okay, so it will use its motors. Okay, so they are also called as the thrusters. Okay, so how you put this one into the block diagram? Okay, so what we do is, so basically we have this Vikram lander. Okay, so then we have this desired altitude here. Okay, desired altitude. So once you have desired, here you have actual altitude. Okay, so this lander is controlled by these actuators. So we call these are the thrusters. Okay, so these are nothing but the motors. Okay, so this attitude we will measure by using something a measuring device. So something called like gyroscopic sensors. Okay, so these two things we give it to this summing point. Okay, which produces this error signal. Okay, so that error signal we give it to the controller. Okay. Okay, so then the controller will actuate the motors accordingly. So motors will respond and the lander will take that as input and change its course. Okay, so this is how we can put it into the block diagram. Okay, so this is also a simple example. So where the my main intention is to say that, okay, so first you understand the problem, put that into the block diagram. Here, these are very simple cases. Okay, but in real case, so a system is not like you have input and you have output, a general system. Okay, inside system you'll have simple components, or you can say that you have uh, many subsystems. You have many subsystems. Okay, so all the many subsystems also will come into this picture. Okay, so you have to take care of all those things. Once you start putting them into the block diagram, you will understand those aspects also. Okay, so I hope this is clear. Any queries here? Any queries? Yeah. So next we'll get into this linear versus non-linear topics. So linear versus non-linear. Okay. So as explained in the video, okay. So let us say you have this function. You have this function. I'm not talking about system. So I'm starting with function. Okay. So it is a linear function. Basic definition says that linear function. Okay. So if and only if it satisfies two properties. So first one is additivity. Okay, so which we call also called as the superposition. Okay, so second one is the homogeneity. Okay, so basically additivity says that, so this is a function which is function of an independent variable x, which is function of an independent variable x. Okay, so here if you give two uh, two independent variables, okay, so that will become, let us say, x1 and x2. Okay, so the additivity says that if you give combinedly as two variables, okay, so that has to be equal to their summation of the individual components. Okay, so this is called as the superposition principle. Okay, so homogeneity says that same independent variable, if you multiply with some scalar alpha, okay, so that has to be equal to alpha f of x. Okay, this is the basic definition. Okay, so this has to be true for all scalars of alpha, for all scalars of alpha. Okay, so let me tell you the simple example. So the function is a linear function if and only if it satisfies both additivity as well as the linearity. Okay, so additivity says that if you give two inputs x1 x2 separately, okay, and if you give the combined input x1 plus x2, that has to be equal to the summation of the individual outputs. Similarly, homogeneity says that the independent variable, if you multiply with alpha, and that has to be equal to and apply to the function, okay, that has to be equal to alpha f of x. Okay, so let me tell you the example one by one, you'll understand in a better way. Okay, let us say if f of x is equal to 2x. Okay, so x in all real numbers. Okay, so first we have to verify the additivity. So the additivity says that, so we have to verify whether this is true or not. Okay, so this is true or not, correct? So first what we do, so first we'll give both in place of x1. Okay, so in place of x, let us say x1 plus x2. From the function, how can we write 2 multiplied x1 plus x2, which is nothing but 2x1 plus 2x2, which is nothing but f of x1 plus f of x2, correct? So additivity is satisfied, yes or no? Additivity is satisfied. Similarly, check the homogeneity. So homogeneity, what we wanted to say, so f of alpha x. Okay, so in the given function, substitute alpha x in place of x. So what do we get? So 2 multiplied alpha x, correct? So that we can write like alpha multiplied 2x, which is nothing but alpha multiplied f of x. Okay, now you see. So homogeneity also satisfied. Okay, hence the system is linear system. Sorry, so don't say system, I'm not saying any system. So hence the given function is linear function. Okay, is this clear? Any doubt, any query? Okay, so now, so let us consider this case now. F of x equal to 2x plus 9. Okay, so now again checking the additivity. Okay, so additivity, what we do? So start with f of x1 plus x2. Okay, substitute x1 plus x2 in place of x in this function. Okay, so that is 2 multiplied x1 plus x2 plus 9. Okay, so which is nothing but 2x1 plus 2x2 plus 9. Okay, which is not equivalent to 2 2x1 plus 9 plus 2x2 plus 9. Am I correct? Because this is basically f of x1. This is basically f of x2. Okay, here what is happening? So the additivity is failed. Additivity is failed. Correct? Similarly, check for the homogeneity. F of alpha x. Okay, so again 2 multiplied, substitute alpha x in place of x plus 9. So this is not equivalent to alpha 2x plus 9. Correct? So this is f of x. Correct? Here the homogeneity also failed. Okay, hence the system is, so it is not satisfying both. Even it satisfies one also and does not satisfy the other also, system is not linear. Okay, next let us consider one non-linear system. Let us say f of x equivalent to 2x squared plus x. So can you tell me, just by looking at this function, is it linear or not linear? You can guess it. Okay, so let's start with that. It is going to be not linear. We can start like first additivity. So x1 plus x2 is equivalent to what? So substitute x1 plus x2 in place of x. So x1 plus x2 whole square plus x1 plus x2. Okay, so this is what? So x1 square plus x2 square plus 2x1 x2 plus x1 plus x2. Correct? Again, this is not equivalent to x1 plus x2. This is not equivalent to what? This is not equivalent to x1 square plus x1 plus x2 square plus x2. Am I correct? Because the problem here is with 2x1 x2 term. Okay, so hence this is failed in additivity. Okay, similarly, what about the homogeneity? So f of alpha x. Okay, so that is alpha x whole square plus alpha x. Okay, so let's say if you take alpha out, okay, you will get what? Alpha x square plus x. Okay, that is not equivalent to what? Alpha x square plus x. Correct? Because the homogeneity says that that has to be equivalent to alpha f of x only. But here you are getting extra alpha. Okay, hence the homogeneity also failed. Hence the system is not linear. Okay, so quickly another example. Okay, so we saw the first example as something like this. So f of x equal to 3x. Okay, we said this is linear. Okay, we found it is satisfying both homogeneity and additivity. But now, so there I have given x belongs to real number. Okay, now, so I'm going to change like this. X belongs to 0, 2, 4, 6, etc. Okay, so x takes only the even numbers. Okay, so now can you tell me? Okay, so let's start with that. F of x1 plus x2. So that takes 3x1 plus x2, which is equivalent to 3x1 plus 3x2. Okay, so this is equivalent to what? F of x1 plus f of x2. Irrespective of, you take any number from this series. Okay, any number that will be true. Correct? Hence, additivity is satisfied. Okay, second. So to check the homogeneity, f of alpha x. Okay, so now tell me, what should I do? Can anybody tell me? So how do we proceed from here? Can I directly substitute alpha x into the function? Can I write it like this? 3 multiplied alpha x. Can I write it like this? Can I write it like this?
Yes, ma'am.
Again, I'm giving one more chance. Can I write it like this? Can I write it like this? So check this and tell me. Can I write it like this? No, we cannot write. Why? So what is basically this function says? Okay, what is basically the given function says? The given function defined as f of x is equal to 3x. Okay, f of x is equal to 3x. X belongs to 0, 2, 4, 6, etc. only. Am I correct? Right?
Yes, ma'am.
But I can use if I am taking x as 0, 2, 4, 6, etc. only. Okay, but here in place of x, what I am doing here?
Alpha x.
I'm substituting alpha x, not x. So what does it mean? That alpha x must be belongs to 0, 2, 4, etc. Otherwise, I cannot use this function. Am I correct?
Yes.
Yeah. So, but here, what is the basic definition of linearity says? So don't forget this. So this has to be true for all scalar values of alpha. Got it? This has to be true for all scalar values of alpha. Okay, not just for 0, 2, 4, 6, etc. What if I take alpha is equal to 1.2? Okay, if I take alpha is equal to 1.2, okay, so I cannot use that function, correct? If I take alpha is equal to 1.2, I cannot use that function. Am I correct? If I take alpha is equal to root 3, I cannot use that function. If I take alpha is equal to -2, I cannot use that function. Okay? Yes. Because for alpha, okay, so let's say 1.2 root 3 -2, okay? So if alpha is this case, f of alpha x is not defined. Correct? If alpha takes those values, my function is not defined. The function is defined only for this set of values. Okay, so this function is not homogeneous. It is specific values. It is applied for specific values only. Okay, hence, so homogeneity is not satisfied. Hence, the system is not linear. Is this clear? So alpha, it has to take all scalar values. Okay, any queries? Okay, next. So similar thing. Let's say same way we have f of x is equal to 2x. Okay, so here where so x equal to, it takes some vector as a0 or x equal to some 0b, where a comma b they belongs to a real line. Okay, so a and b can take any values. Okay, just by looking at f of x is equal to 2x, don't say that it is directly a linear function. Okay, so for example, here let me take, since A and B can take any real values. So let's take x is some 3, 0. Okay, because 3 is allowed. So or we can take x is some 0, 1.2, 0, 1.2. Okay, so we can, this is the load, correct? This is the load, but this is like x is equal to 1.22 or x is equal to -2, 6. Okay, as per the problem, this is not a load. Am I correct? Right. So suppose now let us apply this additivity. So what we should do, f of x1 plus x2. Okay, so I write it like this. So f of a0, okay, plus the x2 value is 0b. Okay, so that will be like f of a comma, sorry, f of what do I get? F of a b. Am I correct? Yes or no? Now tell me, is it additive or not? Can anyone tell me? Is it additive or not? Anyone? Can anyone tell me?
Hello.
Is it additive or not? Yes, yes.
Ma'am, can you please again solve the above statement? I can't understand why this allowed and not allowed.
Which one?
Ma'am, x is equal to
No, this is, yeah.
ma'am,
See,
in
this
one
is the
step
problem
it.
given.
Yes, ma'am.
No, this is the problem given. What it says, f of x is equal to 2x. Okay.
Yes, ma'am.
So x can take only this format or this format.
Okay, okay.
Okay, I can take x like this or like this. Yes or no?
Yeah. Yes, ma'am. Yes, ma'am.
I cannot
Okay.
take x like this or like
Okay, okay.
this.
Understand.
Yeah, yeah. So I'm just giving an example. Okay. Now you see that I'm trying to taking x like this, which is equivalent to this. Am I correct?
Yes, ma'am.
So if that is the case, I cannot use that function. I cannot use this function. Correct?
Yes, sir.
Why? Because f of x is equal to 2x, my x has to be like this only or like this only. But
Okay.
I'm trying to use x like this. Okay. So it means that this is undefined. Am I correct? And also, if you consider f of x1 plus f of x2, what does it takes? So that will be like a0 plus 2 multiplied 0b. Am I correct? So that will be like 2a 2b. Correct? So this is undefined and this is well defined. So simply f of x1 plus x2 is not equivalent to f of x1 plus f of x2. Correct? So additivity is not satisfied. Am I correct? Additivity is not satisfied. Okay. So similarly, you can verify the homogeneity also. Okay. So homogeneity, what we do, f of alpha x, correct? What we can do, f of alpha. So the x, what we can take, a0, correct? So that is nothing but what? F of alpha a0. Am I correct? Now I can use this. Why? Because this looks like a comma 0. So in the this element is 0, the above element is non-zero. Okay, so I can use that. So that will be like 2 multiplied alpha A 0, which is nothing but 2 alpha A 0. Okay. Then alpha f of x. This is what we wanted to verify these two are correct or not. Okay. So alpha f of x. What is f of x? F of x is nothing but what? A0. Am I correct? So that is nothing but alpha. Okay. What is this one is? This one is nothing but 2 multiplied a comma 0. Okay. Which is nothing but alpha 2a0. Which is nothing but 2 alpha a0. Okay. Now you see these two are equal. Am I correct? F of alpha x is equivalent to alpha f of x. Okay. This will be true even if x you start with 0b also, because that is another option, right? So homogeneity is satisfied. Homogeneity is satisfied, right? But additivity is not satisfied, hence it is not linear. It is not linear. Is it clear? Yes. So, are there any queries? Are there any queries?
Sir, for the homogeneity, I have a doubt.
Yes, yes.
For the homogeneity, we have to consider all the value of alphas. Like
Yes,
we
all
are not allowed,
scalar values of alpha.
right? We are not allowed to write a condition like alpha is multiple of 2, then only it is satisfies homogeneity or something.
Sorry. Yes, correct.
Like we can write the condition or not? Like alpha is multiple of 2, then the function is homogeneous or something.
Where which alpha? No. Here you check. You take any alpha. Okay.
Means we are not
You
allowed
take
to write
any alpha.
condition.
No, not needed.
Okay.
Here
Okay.
you take any alpha. Let's say alpha is equal to 1, -2, pi by 2, anything. Okay. This will be non-negative only. Sorry, this will be non-zero only. Correct? And the other element is 0 only. That's what we want here. Because A and B are in the real number. Okay. So now in today's session, we have just verified the given function is linear or not. Okay. So function is linear or not. Okay. In the next live session, okay, we will verify the, we will first define the what is the system which will have both input as well as output. Okay. How to verify the linearity. Okay. For the systems. And then we will also do the examples on the other classification of the systems like time invariant, causal, static, and the other things also. Why? Because verifying linearity is very important topic throughout this course. Why? Because throughout this course, we'll be seeing systems, we'll be considering systems, so which are linear, okay, time invariant, okay, linear, time invariant, and causal systems only. Okay, you'll understand why we are considering this, which are also called as the LTA systems. Okay, you'll understand why we are considering only these systems in the later weeks. Okay, so out of all these, verifying linearity is most important aspect. Okay, then the priority comes to the time invariance also. Okay, so we'll stop this session here, continue in the next session. So yeah, book. So I think Sarah has recommended some book in the videos. No. So then I'll do one thing. I'll give the list in the next live session. Okay, both the reference as well as the textbook. Okay. Yeah. So thank you. We have surprise from the next week, next session onwards. Yeah. Thank you.
Okay, ma'am. Thank you.